In this video, I'm showing you the example from the chapter on the book it's called Clinical Decision-Making Toolbox. So the chapter of the book called Clinical Decision-Making Toolbox, and they do a few different things in the chapter. I want to focus on the part that's about the decision tree. So it looks like a tree with branches. The blue square is a decision. So the blue square is the decision whether or not to vaccinate, in this case, whether or not to get a COVID vaccine. And ultimately, we want to make a decision as to whether or not we choose to get the COVID vaccine, the top branch vaccine, or whether we choose not to get a COVID vaccine, the lower branch, no vaccine. So the blue square is the decision whether or not to get a vaccine, and that's something we decide. So we choose whether or not to get the vaccine. The green circles, that's something that nature decides. So if you get a vaccine, say they flip a coin and they decide to give you Johnson & Johnson or Pfizer. And then whether or not you get the vaccine and whether or not you get Johnson & Johnson or Pfizer, there's another green circle, which is nature decides whether or not you die or whether or not you survive. So then we could evaluate the total chance that you survive, the probability that you survive with a vaccine or with no vaccine. And you can see me labeling the branches there. So each branch is something that happens. The blue squares are a decision that we decide. The green circles are something nature decides. And the red triangles are called terminals or triangles, and those are the endpoints. So the blue square, that's a decision node. That's a decision we make. The green circle, that's a chance node. That's something that nature decides. And the red triangle, that's a terminal. That's an endpoint or an outcome. And after each green circle, the probabilities add up to 1. So you choose to get a vaccine. Half the time they give you Pfizer, half the time they give you Johnson & Johnson. If you get Pfizer, 25% of the time, 0.25, 25% of the time you die from the Pfizer vaccine, and 75% of the time you get the Pfizer vaccine and survive. And those probabilities are reversed for Johnson & Johnson. So Johnson & Johnson, only 25% survive if they get it. And then of the people who get the Pfizer vaccine, 75% survive. So the Pfizer vaccine is a little better than Johnson & Johnson. Now you can see me multiplying the triangles together. So the green circle, in a sense, means multiply. You multiply them through the tree. So if you get the Pfizer vaccine, 0.5, and you die from the Pfizer vaccine, 0.25, that's 0.5 times 0.25 equals 0.125, a 12.5% chance of getting the Pfizer vaccine and also dying, a 37.5 chance of getting the Pfizer vaccine and surviving, 37.5 chance of getting Johnson & Johnson and dying, and 12.5% chance of getting Johnson & Johnson and surviving. If there's no vaccine, 25% survive and 75% die, right? 0.25 and 0.75 is 1, or 25% and 75% is 100%. And you can see that the triangles on the first top, on the vaccine part, it's 0.125 plus 0.375 plus 0.375 plus 0.125. That's also equal to 1. So these probabilities at the different parts of the tree always add up to 1. So you can see me circling the probabilities of survival for the vaccine, right? Because there's 2 ways you could survive with the vaccine. You survive from Pfizer and you survive from Johnson & Johnson. So you add those up, 50% overall chance of survival from the vaccine, right? 0.375, that's the probability of surviving conditional on getting Pfizer. 0.125, that's the percent chance of surviving conditional on getting Johnson & Johnson. Add those up. Overall, whether or not you get Pfizer or Johnson & Johnson, 50% of people with the vaccine survive. And then what percent of people with no vaccine survive? Only 25%. That's just the number from the tree that we circled on the bottom part, 0.25. So 0.5, 50%, is greater than 0.25 or 25%, right? The probability of survival conditional on vaccine is greater than surviving without it. So we choose the vaccine, because overall with the vaccine, half of them survive, whereas with no vaccine, only 25% of them survive. So that's how you make a decision to get the vaccine. We look at the probability of surviving with and without it by evaluating the probabilities at different points in the decision tree. So overall, the recommendation would be to choose the vaccine. Higher survival probability.